Yo, yo, yo. Uh, yep. We are back on Big Brain Coding. Today is a lead code and system design study day. So I'll just do some questions and maybe read some concepts. That's the plan today. So, yep. Let's get it. Alrighty. Done. ओके गाने वाने चला देते हैं बढ़िया से कुछ टू कोई यार एपिक एक मिनट Yo, okay. Okay. Count days without meetings. Interesting. You are given a positive integer days representing the total number of days an employee is available to work, starting from day 1. You are also given a 2D array meetings of size n, where meetings of I is start I and end I represents the starting and ending days of meeting I. Return the count of days when the employee is available for work but no meetings are scheduled. The meetings may overlap. ये तो काफ़ी आसान क्वेश्चन लग रहा है. Overlapping intervals is very similar to this question, I believe. But let's try to draw this shit. So let's take this example. Yup. Okay. तुम्हारे पास we have 10 days and meetings intervals are these. So the first point would be to sort these meetings based on starting time, right? That's how we know when is a meeting starting and stuff like that. Yeah, brother. Okay, days can be 10 to the power of 9, meetings can be 10 to the power of 5, meetings of I dot length is 2. What do we need to return? Return the count of days when the employee is available for work but no meetings are scheduled. So first of all, sort this bitch based on starting point, like the starting time of that meeting. So in this example it'll be 1-3, then 5-7, then 9-10, right? And none of these are overlapping. So we take days 10. And are these days inclusive? Like, is this like 3 days? 1, 2, and 3 are gone? Is that? Yeah, inclusive. So we just do 10 minus 3 minus 1. What is the equation? 3 minus 0. Basically, if this is u and this is v, so it will be v minus u minus 1. This many number of days will be deducted from the available days. So it will be 10 minus 3, right? Then 10 minus 7 minus 4, which is 3 again. 10 minus 8, which is 2. So answer will be 2. Now the point is, when the meetings are overlapping, then it becomes a case. Is this overlapping? Yep. When the meetings are overlapping, we again sort the meetings based on starting time. Then we check if two adjacent meetings are overlapping. We can check by just taking this guy and seeing if this is in between these two. If it is, then we delete these two and insert a new interval, which will be this and this. And then we check with the next guy in line. So it is like a, how do we do that? Do we stack it? No. Queue? No. I mean, queue can be done, but yeah, but queue is a problem. We cannot insert. We can insert at the front, but it's big. It'll become a mess. What is the easiest way? So what we can do is, when the intervals are overlapping, when they keep on overlapping, we do this operation, right? Brother, why am I stuck? If these two are overlapping, then merge them, right? Okay. What data structure would be optimal for this kind of situation? Just a list? List can be fine, but I'm thinking of some big brain solution here. I mean, I can do it like a two-pointer approach. Let's say we have multiple intervals, right? So there is a left pointer here, and there is a, let's call it L, and let's call it I, or fuck it, let's do this simple. Let's call it I, right? We pick this interval and we iterate j over the remaining ones. We check if I and j are overlapping, we merge them, and we move j. Basically, I edit this one, right? I edit the current one. When they are not overlapping, I will deduct that number of days, and then I'll move I to j and j plus 1. That's the approach. So it's kind of a two-pointer thing. Let's see if it works. Here we don't need any queue, just a list will work fine, but we need to sort these meetings based on the starting point. That's the point. That's the situation. Now sorting would be n log n, 10 to the power of 5. So this is an expensive solution, kind of, but that's the maximum time complexity that we will have here. while j is less than, let's do one thing here. Let's call it p equals sorted meetings dot size p, while j is less than p, and is overlapping sorted meetings dot get I and sorted meetings dot get j. Then what do we do? If they are overlapping, we need to merge them and move j forward, right? Basically, let's do one thing. So current equals sorted meetings dot get I. If the current interval that we selected here is overlapping with j, then current of 0 is fine, but current of 1 will be the thing of j, right? Sorted meetings dot get j of 1, that's all, and j plus plus. After that, j will be in a position where there is no overlap. Then we do I becomes j, right? So we should probably do a while loop here just to not fuck up anything. While I is less than p, that's it. And then what do we do? Days let's take a count. Busy days equals 0. Then we do busy days equals plus equals current of 1 minus current of 0 plus 1, and at the end we simply return days minus busy days. Let's see if this works. Of course, is overlapping is not defined, so we need to do that. Private boolean is overlapping int a int b, return if a of 1 is greater than equals b of 0. And I think I need to upgrade this compare function. What if they are equal? If they are equal, then we need to compare the second, the end I, right? So if a of 0 is equals b of 0, then return integer dot compare a1 b1. Otherwise, return integer dot compare a0 b0. Now okay, it works for the test, I mean the example cases. Let's see. Wrong answer. -2 1. What happened here? 3 4 4 8 2 5 3 8. What the fuck? So we sort them. What happens then? It becomes 2 5. Then it becomes 3 4, right? Oh shit. Okay. Fuck. So our is overlapping function is kind of a trash. I mean, okay. What are the cases where two intervals overlap? Let's say this is the number line, right? If either this guy is in between here, right? So let's say this was 1, 2, 3, 4, 5, 6. So we have an interval like this. Then we encounter an interval like this. There can be overlaps like this, could be like this, right? Could be the same, but they're not same. Could be this, but this is same as this. So just kind of a three cases. So this is redundant, and this case where both of them are inside this interval can be covered just by this one or this one, right? No, by this one. So we don't need this. So we just compare this guy. If this guy is on the edge of this or further, or if this guy is in between these two, right? Yeah, so this or a b of 0 is greater than equals a of 0 and b of 0 is less than equals a of 1, then they are overlapping, right? Yeah, let's see if this works. Come on. Again, I think okay, now this is a kind of shit. These are just edge cases that I need to dry run. I mean, okay, sorting this would be 148 to 9. Let's get back on here. Overlap could be this one, right? Now 3 is okay. Let's see. My this logic is still flawed here. This logic is still flawed. So current of 0 will be math.min of current of 0 and uh, 0, right? And current of 1 will be math dot max of current of 1 and sorted of 1. This is the logic. Yeah, I think this should be fine, I believe. Yeah, but the performance is pretty bad. What happened here now? Is this expensive? This is expensive for sure. This is not expensive. What are the decent solutions? Let's take, instead of tracking available days directly, it's easier to track that have meetings and subtract from the total. Sort meetings by start day to process them in chronological. Merge overlapping meetings to avoid counting the same day multiple times for each merge. For meetings in meeting, if not merged meetings Okay, he's preparing the merged meetings beforehand and then just doing this thing. Is that better? And I think it's written there that no 2 days are equal here, right? No, could be. I don't know, man. Yeah, and this is redundant because, yeah, this is redundant. Yeah, it's kind of. Doing the same thing, but I don't know, man. Let's see if I don't do this, will this work? Yeah. Okay. So that improved this performance. So we are not checking for equality here. Okay, cool. Good question. Good question. So this covers merge intervals as well, which is in the neat code or blind 75 list. Epic. Neat code practice. If we see here, merge intervals, is there? Yeah, intervals, merge intervals. This is the same question as that. Okay, okay. Let's do. Yeah, let's do one concurrency question. So in lead code, there is a secret section called concurrency, which deals with concurrency based questions, and we'll be learning in Java. So concurrency. Okay, just these. What? That's all? What? Oh shit. Okay. Print in order. Suppose we have a class, public class foo, which has three functions, first, second, and third, and they just print the words first, second, and third. The same instance of foo will be passed to three different threads. Thread A will call first, thread B will call second, thread C will call third. Design a mechanism and modify the program to ensure that second is executed after first and third is executed after second. We do not know how the threads will be scheduled in the operating system, even though the numbers in the input seem to be imply the ordering. The input format you see is mainly to ensure our test's comprehensiveness. There are three threads being fired asynchronously. Okay. I have done this in C++, I believe. Yeah. But it was 3 years ago. Fuck. I don't remember any of that shit. But I believe it. I need to revise these concepts, man. Let's go to Big Brain. Home. Is there any concurrency based stuff? Nope. I never made concurrency notes. Okay, let's do. Okay. I had the notebook, but I need to revise offline. No worries. Okay. Let's try to raw dog it. I mean, what would be the approach? One could be I can keep an integer value shared among these threads, and each function will check if that integer value is expected, then only it will execute. Otherwise we just return. And when that expected value is there, we execute and change that integer value. Now, one thing to notice here is that integer value should be accessed by one thread at a time. For that we need critical section. Now here it gets, sketchy. I'm not sure about, I'm just talking out of my ass right now. So I would rather look up a solution first and then try to decode what's happening, rather than just talking out of my ass and just bullshit around here. So first I will see my old solution in C++, and I will check if I can take some inspiration. Let's see this. What? Okay. Oh fuck. Yeah. So this guy has an integer value, 0 initial, 1, 2 or 3, then a condition variable CV. What the fuck is that? I can't read C++ anymore. Unique lock mtx, mutex, condition variable CV. Let's see this one. It's the same shit. What? Yeah, I was kind of in the same neighborhood here. We have an integer value, we have a mutex where we acquire lock, right? Unique lock, mutex lock, acquire lock, cv dot wait lock, return last executed function equals 0. What the fuck is happening? Wait until last executed function is 0, initial condition. Print first, outputs first, do not change or remove this line. Last executed function is changed to 1, cv dot notify all. What is cv? Condition variable. What is the equivalent of that in Java? Now, yeah, this is I'm in fucking unknown waters right now. I know what a mutex is. Mutex is like a fucking binary lock, right? What is a mutex? Mutual exclusion is a synchronization primitive used in concurrent programming to ensure that only one thread or process can access a shared resource at a time. It is used to prevent race conditions where two or more threads might try to modify the same resource simultaneously, leading to inconsistent or erroneous behavior. Locking and unlocking. A mutex works by allowing a thread to lock it when it needs to access a shared resource. Once a thread locks the mutex, other threads that try to lock it will be blocked until the mutex is unlocked by the thread that currently holds the lock. So I believe we are not calling unlock anywhere. So this thing, right? cv dot wait lock. What is cv? What is the fucking... We are not unlocking this, right? I believe when this goes out of scope, it automatically gets unlocked. That's what I'm assuming, and I think that is correct. cv dot wait lock. lock dot notify all, lock dot notify all. Synchronized on two objects. I need to study all of these concepts, man. Semaphore. Yes, semaphore is a value, right? S2, S3. Still, he's using just one value. Condition variable. Let's see some others. Same shit, same shit, same shit. Java 9 different solution. Exchanger, barrier, latch, lock, etc. Still learning. There are just so many choices Java gave us to handle multi-threading. I'm sure there are more ways to do this and my knowledge is limited. I will come back to this post and improve and add more comparisons once I understand better. For synchronized solution, if a thread calls wait but no other threads are performing a corresponding notify or notify all, those threads will remain in the waiting state indefinitely. If a thread calls wait but no other threads are performing a corresponding notify or notify all, those threads will remain in the waiting state indefinitely. Moreover, if your application creates an excessive number of threads that all try to acquire the lock using synchronized blocks, it could lead to resource exhaustion or decreased performance due to excessive context switching. We need to put wait in a loop also. Check the condition in the loop. Java does not guarantee that the thread will be woken up only by a notify, or because of this property, the loopless version might work on your development environment and fail on the production environment unexpectedly. A thread can also wake up without being notified, interrupted, or timing out, and a so-called spurious wake up. While this will rarely occur in practice, application must guard against it by testing for the condition that should have caused the thread to be awakened and continuing to wait if the condition is not satisfied. In other words, wait should always occur in loops like this one. Okay, this article seems nice, man. Expand this shit. Yeah. So synchronized object, while some condition we wait. Okay. Volatile keyword ID is quite different from other mechanism. It's to tell JVM to put the variable in the main memory of the server instead of the cache or the CPU. When we have multi-threads running on the server, they run on different CPU cores, I think, then using their own caches. So one CPU may get older value when another CPU already updated the value in its cache. Volatile keywords ensures that any thread reading the variable sees the most recent modification made by any other thread. We should understand that this is on web server level, not database level. A often brought up question during interviews is when we have multi web servers trying to update the same data in database, how do we make sure we are getting the latest update? Volatile will have nothing to do with that. Another question is about Redis. Is there a similar mechanism in Redis? Answer is no. Since Redis is single threaded by default, that's how it's built. How to sync up Redis servers in different data centers is a totally different challenge. Okay, volatile int method completed. Method completed is 0 initially. When in the first function we run it, method completed is 1. While method completed is not equals 1. Print second run. Yeah, this is very easy. So this volatile goes into the main memory of the server. Okay. Then we have exchanger. What is exchanger? So we define two exchangers. Then we try to run exchanger 1.2.exchange true, signal that first has completed. Otherwise, catch the exception. Then wait for first to complete. Exchanger 1.2.exchange true. What the? Print second. Okay. So this, I mean, what? What is happening? Now this is confusing. Like, is it switching the value and even like checking? What is happening behind the scenes of this? I didn't get that. Cyclic barrier. What is it? Cyclic barrier. I don't know. Cyclic barrier 1 and 2. The value is 2 in the constructor. Then we start the first thread, barrier 1.await, broken barrier exception. So there is no explanation. Slash lock condition atomic boolean. Atomic boolean provides a simple mechanism for ensuring visibility and atomicity in thread safe operation without explicit synchronization. Ensures that threads don't waste CPU cycles actively waiting for conditions to be met. However, the while loop continuously polls for the state change, potentially consuming CPU resources. Everybody has seen these three. Semaphore, okay, first, print first dot run as one dot release as one dot record. Okay. I still see that in terms of CPU efficiency for Java multi-threading mechanisms that put threads into waiting state without actively consuming CPU cycles are generally more efficient. Semaphores, countdown latch, cyclic barrier, or even wait notify mechanisms tend to be more CPU friendly because they allow threads to wait without constantly checking completion. Here is a comparison. Ah, who is this guy? What the? Bro. Insane. Oh, this guy gave up in 2025, I believe. How many years? Every day, man. What? That's great. Amazing. He crushed it in 2024. Crazy. And he did some contests as well, man. Nice. Okay. So let's try the volatile one. That seemed pretty straightforward. So the point is just to use a volatile static variable, public static volatile int. Is that, yeah, int completed method completed. Initially it is 0. Okay, just a while loop without anything, so it'll just be stuck there. Okay. Okay. I mean, yeah, it will be inefficient because it is fetching from main memory. Okay. So we just learned that volatile keeps the variable in main memory. That's a straightforward explanation, right? Good learning, good stuff, good stuff. All right. Now Let's see one system design question and then we wrap it up. So, okay, I need to get my notebook for that, man. This one. Come on. Okay. I was thinking of seeing key value store system design. Like how is like Redis designed? What is the thing? Let's see if I have notes for that. Rate limiting, yeah, alright. Replication, consistency, system architecture, unique ID generator. This is also cool. URL shortener is pretty cool. Web crawler is also cool. Consistent hashing. Notification system. These are like high level shit, man. Do you have a key value store, brother? News feed. Is that a key value? Okay. A key value database is a non-relational database, so there are no fucking joins and stuff. Non-relational means I immediately go to like MongoDB, fucking Cassandra, like, right? Cassandra is a NoSQL, Amazon stuff, right? Apache, yeah, NoSQL. Yeah, brother. Non-RDBMS, non-relational database. Yeah, NoSQL. What is the equivalent of Cassandra in AWS? What? Yeah, they have Cassandra, right? Straight out of the box. Okay, perfect. Okay, so how do I do that? I'm reading from notebook here, but I have a screen to be shared. Yeah, let's pull up Excalidraw. So a key value store like Redis. How does that work? Okay, let's write it down. Key value store. NoSQL. Each unique identifier is stored as a key with its associated value. Yeah, that's what a key value store is. Amazon Dynamo Memcached Redis. Design a key value store that supports the following operation: put key value and get value for that key. So there's two operations: put key value and get the value for that given key. Now, yeah, we need all of that stuff like distributed servers, multiple fucking threads, stuff like that. We need to handle all of that shit. Consistency, redundancy, availability, fucking all of that features that we need. Properties of the key value store. The size of the key value pair is small, so we can't store fucking movies in the value of that pair. It should be less than 10 KB. Just document 10 KB is good. I mean, we can't store megabytes. We can store a link to that doc, right? That's how we optimize. So the value will be approximately 10 KB, less than 10 KB. I mean, this is the max size. Ability to store big data. What the fuck is big data? What is big data? I mean, it's just large amounts of data. structured, semi-structured, or unstructured. So all the logs and stuff is big data. Volume, velocity, variety. What? Okay. What are the examples? Healthcare, medical records, research data, sensor data. Finance, transaction data. Yeah, it's big data. There are there are fucking billions of transactions happening. Retail, social media, IoT, government and security, surveillance camera. Oh, okay, I get it. Yeah, but NSA captures everything and they analyze shit and they just, you know, privacy isn't a thing in NSA. Anyways, I'm sorry. I'm sorry, FBI. Don't get after me now. I apologize. Okay. Availability, scalability, automatic scaling, tunable consistency, low latency. Okay, we need all of this shit. Availability means it should be available to serve requests. It should be scalable. Like if I want to process billion requests, it should be able to do so. Automatic scale. I don't need a fucking DevOps person clicking on buttons to scale up. Tunable consistency. What the fuck does that mean? Consistency. Low latency. Yeah, it should be quick. A single server key value store is stupid and cannot be scaled, so we won't discuss that. Yep. True statement. Distributed key value store. A key value store present on multiple servers, but before that, let's understand gap theorem. Okay, we are getting in deep into it. Okay, let's understand gap theorem. So gap theorem is basically fucking three circles. Yeah, three circles which do not have a common intersection point. So we only have two circles intersecting at a point of time, like this. And these three circles are this is consistency, this is availability, and this is partition tolerance. Okay, so consistency means the data should be same if we get it now or we get it a few milliseconds later. Like other write operations shouldn't fuck that up. That's what consistency is, right? All clients should see the same data at the same time, no matter which node they are connected to. Yep. Since we have a distributed key value store, distributed means there are many servers serving requests, right? They should all return the same shit, right? Let's say my server in North Korea is trying to get a trying to get a value for some key. Let's say it connects to fucking any of this. This is my key value store solution that I'm building. These are my multiple servers, distributed servers, right? If it hits through a load balancer, any node, it should return the same value, no matter what node it is trying to connect. That's all. I mean, the load balancer decide from where to get that, but yeah, we get the point. Okay, what is availability? Any client which requests data gets a response even if some of the nodes are down. Yeah, that's why we have multiple of these. If one of them fails, like power goes out in a data center, others should be able to serve that request. That's what availability is. And the last is a tricky one. A partition indicates, what is a partition tolerance? Partition indicates communication break between two nodes. So partition tolerance means the system continues to operate despite network partitions. Okay. So now, since we talk about consistency, right? It should return the same data no matter which node we are trying to get it from. So there should be some syncing between these nodes, right? By syncing, I mean they either share data or yo mahol pura kodi. Yes, sir. Trying to get back on the grind. It's time to switch. Currently getting into system design and concurrency concepts, because SD2 interviews are based around those. So yeah, that's the scene. Currently learning cap theorem, epic cap. Let's ask chat GPT, what is partition tolerance? I will get to the grind queue for this year. Nice. Partition tolerance is one of the key concepts in distributed systems and is about explain with in brief and with a diagram probably. I don't need to read a book about partition tolerance. Partition system's ability to function properly even when there is a network partition. A network partition occurs when parts of the system are unable to communicate with each other due to failures, network latency, or other issues. This is one of the core concepts of CAP. Okay. During a network partition, the system will ensure data consistency, but may not always be available. Some reads or writes may fail. Okay. So network partition is basically a communication break between two nodes of the same application. Let's say if this was our KV store, if two of the nodes can't communicate with each other, then there is a partition. If we want to tolerate that, we need to simply redirect all those requests to other nodes, right? So cap theorem, what does it say? We can only achieve any two of these three conditions. We can't have all three. So what is partition tolerance? How do we tolerate these partitions? Okay. A network partition occurs when so what do we do? What happens when a partition occurs between nodes? When a partition occurs, it means that the network that connects those nodes has become temporarily unreliable, to become isolated from others. This partition could happen due to network failures. Okay. Nodes can't communicate. Data inconsistency. Yeah. So one node can lag behind, right? One node can have old values. So we either just, this gets isolated, right? So we simply say that we can't serve requests from here, so you are temporarily disabled. We put a timeout, some timeout shit. By timeout, I mean we can't serve requests, so all of those requests will be redirected to other servers. That's the point. This is partition tolerance basically, right? Let's make another clear diagram. If this is a key value store, and if there are multiple servers serving for this key value store, and all of these are interconnected, I mean they can talk to each other because they need to sync their values and be consistent. But if one of the communication fails, right, and we know that communication failed because it's no longer 200 response from this node for syncing, so we simply say that we can't serve requests from this node, so we redirect all of the incoming requests to these 3 servers. This becomes temporarily disabled until this connection gets up and running again. This is partition tolerance. So if we have this concept, I mean if we have this feature, we can't have consistency and availability at the same time. We can see here if now, yeah, in this case partition tolerance is there. Yep, we can still serve requests from these 3. Consistency is still there, yes, because these 3 are in sync. They serve the same data, they give the same value for every key. But availability is not there because this server is not functioning. This is not available. Now if we do the other 2, I mean partition tolerance and availability, how will that work? Now we can say that, yeah, this network is faulty. I mean we can't contact this node, but still it will be able to serve requests. Now user can fucking send a request to any of this, but this will contain stale data or old data. Let's call it stale. So it won't be consistent. I mean this will return a value X, this will return fucking Z. So this is not consistent, but it is available. So that's the point of cap theorem. Only 2 of these can be achieved at a time. Okay, good revision. Okay, we can either have CA systems, CP systems, or AP systems. We need to make a choice what we need for our key value store. I believe in CA systems. No, CP. Consistency should be there and partition tolerance should be there. I mean I 100% believe in consistency. Yeah, Virat Kohli, Ronaldo, that's why they're great. System components, data partition, data replication, consistency, inconsistency, resolution, handling failures, systematic. Okay. Okay. Now we have understood the cap theorem. We get into the details of how we store large amounts of key value pairs in our database, which is a NoSQL database. Okay. So when there are a billion records to take care of, we need to divide that data in different drives. If we keep 100 TB of data in one single hard drive, the disks will keep spinning. You know what a hard drive looks like behind the scenes? It's just a fucking stack of disks. and there is a read fucking instrument. It just goes through which sector to read from, and then it gives the value, right? Hard disk internal diagram. Yeah, there are multiple stack of disks. ARM assembly. Yeah, so each disk has an ARM to read and write to. There are sectors and tracks. So yeah, so if there is 100 TB hard drive, we just fucking for each get and 100 TB hard drive and 1 billion requests. This hard drive will be cooked, right? It'll be cooked. We don't need that. So we probably need some sort of division of this data. That's what we call data partition. Data partition. Okay. Store them in multiple servers. Now, let's say for this 100 TB data, instead of storing it in one server or one computer or one hard drive, whatever we want to call this, if we store 20 TB in one, basically we have 5 servers, 20 TB data in each, right? Now the point is these servers are in different location, right? They are not connected to one compute device which can access these drives. I mean, it is, which is our application, right? API or our app server. App server would be appropriate. App server. Yeah, but these are also individual servers. DB servers, we call them. DB servers. DB servers. DBS. Yeah. One second. Let's see. Okay. Now these DB servers might not talk to each other, right? So, and where is this 20 TB coming from? It is coming from the app server, right? When we do a put request from here, from the user's point, right? User sends a put to the app server. Now this should fucking decide which DB server to pick and store it to. For that, we need a strategy, right? Now, this strategy is called consistent hashing. I'm also trying to recall what the fuck is consistent hashing. I think it is distribution of data based on some ID, like some mod, some math or shit like that. I don't know. Let's see if I have consistent hashing written down somewhere. Consistent hashing, brother, give me consistent hashing. The fuck is Multi-leader replication, brother. नहीं है अपने पास. Okay, let's see what is consistent hashing from ChatGPT. What is consistent hashing? Consistent hashing is a technique used in distributed systems to efficiently distribute and access data across multiple nodes or servers in a way that minimizes the need for data to be rebalanced when nodes are added or removed. It's especially useful for systems that require scalability and high availability. Okay. एक काम करते हैं. एक आर्टिकल था जो पढ़ा था मैंने, कंसिस्टेंट हैशिंग. इस पे आर्टिकल लिख रखा है भाई मैंने, तभी तो मैं सोचूं भाई कुछ तो गड़बड़ है. There is an article here. System design. Introduction नहीं हमें चाहिए. Okay, let's see. Beginner friendly introduction to system design. इसमें नहीं है. The fuck is this? Oh. Nah. भाई कहीं तो लिख रखा था यार. इसमें है क्या? Consistent hashing. कहाँ लिखा था भाई? Shit man. Fuck. इसमें है क्या? इसमें there's no way. Damn bro. DSC DevOps. Let me find that, brother. Let me find that shit. Let me find that, bro. GitHub. Oh. Consistent hashing नाम की चीज़ है यहाँ पे. कुछ तो होना चाहिए यार. सर्च कर सकते हैं. Can I search? And why am I not signed in? Fuck. Okay. Projects. इसमें हम सर्च करेंगे क्या? Consistent hash. अच्छा, लो लेवल डिज़ाइन में. ओह, कंसिस्टेंट हैश. इसके बारे में लिख रखा है. डिस्ट्रीब्यूटेड कैश. ये रहा. What? ये रहा. Theory. Microservices consistent hashing. Okay, let's see. Have I fucked it? Consistent. Fuck. Hashing. Microservices consistent hashing. Is it a PDF? LLD में था राइट, तो कहाँ गया LLD distributed cache? What? Shit. कुछ डिलीट करा क्या मैंने? नहीं यार, कंसिस्टेंट हैशिंग का कोड भी लिखा हुआ है ना. What the fuck? Redis. कहाँ गया भाई नोट? शीट मैन. ओके, न्यू विम है, LLD में हो सकता है. सीट सेलेक्ट, DSA, पोर्टफोलियो, इसमें हमने देख लिया, इसमें नहीं है. ओपन सी गुआवा, ये तो पुराने आ गए चीज़ें. इसमें ही हो सकता है भाई. डिस्ट्रीब्यूटेड कैश में गए, यहाँ पे रीड भी नहीं है. फक. github.io. फोक ब्रदर, इतना पुराना थोड़ा ही हो सकता है यार. डैम. GitHub. पोर्टफोलियो V2 है, पुराने पोर्टफोलियो में है क्या? नहीं, देयर इज नो वे. ओपन CV गुआवा. शीट. ओके, नहीं मिल रहा तो कोई बात नहीं. और ये साइट नॉट फाउंड एग्जैक्टली, कोई बात नहीं. ओके, कंसिस्टेंट हैशिंग. is a distributed hashing scheme that operates independently on the number of servers or objects in a distributed hash table by assigning them a position or an abstract circle. हाँ basically overall क्या है, एक circle पे हम we distribute data on an abstract circle such that it is distributed evenly and it is easier to, I mean, track. Like if we get a request for getting a key, we immediately know using a formula where that key is stored, I mean which part of the circle, which sector of the circle it is stored on. So we can map that same circle among these DB servers. So each DB server represents a certain part of the circle, like an arc or a sector, we can call that. And yeah, that is what, I mean, it's basically a reliable way to know which DB server contains the key that we are looking for. Okay. Automatic scaling and consistency hashing as a big feature. We can add more DB servers on the fly and it won't matter much. I mean, it won't fuck up any, we don't need any redistribution there. That's the best part. I mean, we need minimal redistribution, that's like negligible. Number of virtual nodes times capacity of the server. Yeah, we will get into detail in some other day on consistent hashing, which is, I mean, it's an interesting concept. Data replication. To achieve high availability and reliability, data must be replicated asynchronously over n servers, where n is a configurable parameter. Can be achieved using hash ring of consistent hashing. We can achieve data replication using consistent hashing. Should be I mean, there should be a dedicated day on that. Yep. Consistency. Single data is replicated at multiple nodes. It must be synchronized across replicas. Quorum consensus can guarantee consistency for both read and write operation, n equal number of replicas. A write operation, write quorum of size W. For write operation to be considered as successful, write operation must be acknowledged from W replicas. A read quorum of size R. For a read operation to be considered successful, read operation should wait for responses from at least R replicas. So we need some sort of replication as well. And quorum, like we can specify two values, W and R. These are number of servers that we need acknowledgement from to consider a write operation to be successful. For W write successful, we denote by this, and same for read successful, right? Same for read operation. Okay. The configuration between W, R and N is typically trade-off between latency and consistency. Yep. Consistency model: strong consistency, weak consistency, eventual consistency. Dynamo, Cassandra provide eventual consistency. Inconsistency, resolution, versioning. Okay. Now we are getting into deep stuff. I don't know what a vector clock is, but it's a good point to note. What is a vector? I mean, I need to figure that out. Failures are not only inevitable but common. Failure detection. Handling temporary failures, use sloppy quorum technique. Handling permanent failures. Okay, I need to get into detail, man. Now, the architecture design. I don't know shit about this, bro. Okay. So, in the next stream, I will be reading about consistent hashing. I mean, this is a good topic to learn about. And then next stream, consistent hashing, architecture diagram of key value store. Yeah, that's what we will discuss. Okay, so today was a good productive stream. Learned a lot. I mean, revised a lot. Yep. Good progress. I mean, this is what forces me to study on an everyday basis. Just stream it, man. Okay, so I'll be looking forward to more streams of this kind. If you like this, click the like button. Okay, GG's. I'll see you next time.